All right, so last time I talked about regular expressions, and that was the actual regular expressions in terms of the meta characters and the literals. But that's not language specific. You can use your regular expressions in any programming language, Python, Perl, C, whatever it is. And so the specifics of how to do it in R is what I'm going to talk about today. So the primary functions in R for dealing with regular expressions are grep, regexpr or regex, yeah, I guess regexpr is what you call it, and then sub or gsub, and then there's gregexpr and there's grep-l. Those are kind of secondary, but the main functions are grep, regexpr, and sub. And then there's another one down here, regexec, which is a fairly new function to R. So these guys, so grep basically, you give it a character vector, so it's a vector full of strings, and it will search those strings for a regular expression, a pattern. And if that pattern is matched in a string, it will give you the index of that string in the character vector. So for example, if the first string in the character vector matches the regular expression, the grep function will return 1, right? Because it's the index of the first string. And if the second string matches, the grep will return 2. And if the 10th string matches, it'll return 10. So it'll give you the indices into the character vector where all of the patterns match. grep-l is slightly different. It does the same thing, but instead of giving you the indices of the elements in the character vector that match, it gives you true or false, indicating whether or not that element of the vector matches. Regexpr, all these kind of do the same thing, but they kind of give you different bits of information back. Regexpr looks at a character vector and it sees if the regular expression matches a string in this character vector, and if it does, it gives you the index into the string where the match begins. So for example, if the match begins in the 10th character, then it will return 10. So you'll see how all this works when I'll show you how, I'll demonstrate how they work. And then the sub and the gsub function, they search the character vector for a regular expression, and when they match it, they replace it with something else that you specify. So you can replace parts of a string with something else that you want to replace it with. And then the regexec function is just easier to explain by showing you how it works. The explanation is just bizarre. So I'd rather not print it out for you. So I'm going to read in this data set. This is the Baltimore City homicide data set that I made for. So this homicides.txt file is on the Course Plus website. It's zipped up. You can just download it if you want. And you can read it with the read lines function. So it's just one line per element of data, right? So every line is like this long string that I kind of cut and pasted from the JavaScript, right? And so the first line looks something like this. But even though I've broken it across, multiple lines, you can imagine it all just kind of going across in a single line, right? So this is one string, right? And the entire vector, this is a character vector that I think is like has 1,250 elements in it, right? So every element of the vector is a string, just like this one. So a couple things just to point out. First of all, there's a latitude and longitude for where the person was found. So you don't have. So you get street addresses here. So there's like 3400 Clifton Avenue. That's the street address. But you don't have to geocode the address because the address has already been geocoded for you. So you get the latitude and longitude of where that person was found. You get the cause here. The cause is here, so this is a shooting. Where the person dies, so this person died of shock trauma, University of Maryland. This is the date here. A little descriptive information about the person here. And then, of course, the person's name here. So that's what, and then this is just another entry here. So for example, so one of the things that you might want to do is maybe extract all the records out of this data set that are victims of shootings, right, as opposed to other types, other causes of death. And so what would you do to do that? Well, there's a couple indications of what the cause of death here. One is that there's this little thing here called icon homicide shooting, right? And the reason is because on the map, the little flags that they put in are different colors, right? So red was the shooting, and green is something else, and black is something else. So there are probably different little icons here that indicate, what the cause of death was. And also, there's a little field here called cause. So maybe we can look on that too. Okay. So I can grep on this icon homicide shooting thing, right? And when I do that, I get 228 elements, right? So that seems a little low. And one of the reasons is because in the first entry here, you see this, it says icon homicide shooting. But then in the 1000th entry here, it says icon underscore homicide underscore shooting. So that's a different name, right? So it's not. So grep isn't going to match this, right? Because I gave it a literal string. I told it to literally match this string. So it's not going to match anything that doesn't look like it. Okay. So that's why it only gave me 228. So what if I say, okay, we'll match this icon homicide shooting, or, which is the pipe here, the solidus, icon underscore homicide underscore shooting. So now I can match either one, right? And then I get back 1003, okay? So that seems more like it. If you remember from the little bar graph thing, the vast majority of the homicides were shootings. I can also grep on this cause field. So I'm going to look for cause, colon, space, shooting, right? This is a literal, there's no pattern here. It's just a literal string. And then I get 228. So that, again, that's missing some. And one of the reasons that sometimes the shooting is capital S and sometimes it's lowercase s. And so I can give it a character class where I say either capital S or lowercase s, and then the hooting. And then when you do that, it gives me back 1003. So if you didn't do all this, one of the things you might be tempted to do, but first is just grep on the word shooting to look for all the ones that where shooting was the cause of death. And you'll notice that actually that returns back 1005. And so why is that? Why are there 2 extra when you just grep on shooting? So what I can do is I can get the indices of this vector where this matches here. So here when I match on cause and then shooting, I get a set of indices that I save to an object called I. And then when I grep on just shooting, I get another set of indices that I save to an object called J. And when I look at I and J, you see that I has 1003 elements in it, and J has 1005. And they look awfully similar. At least the first couple entries look similar. So what I want to know is how are these different, right? So the setdiff function is quite useful. What setdiff does is it says take this vector and subtract out all the elements of this vector that are the same. Okay, so it's in mathematical notation, it's kind of like the backslash, right? It's in the set operations, it's the backslash. It's so take the vector of indices that are in I, and remove all the ones that are duplicated in J, and then show me what's left over, right? And it looks out there's nothing left over, right? So so all the indices that are in I are also in J. Okay, so there's no difference there. But if I reverse it now, if I do set diff J and I say, give me all the indices in I that are in J and subtract them off. So what happens is now I've got 2 left over that are in J but are not in I. Okay, so number 319 and number 859 matched this shooting pattern, but didn't match. But they're also included in this set, but these 2 were also those 2 extra were included in the set that just matched shooting. And if you look at the data, you see why. So this is 859. This is the entry for 859, and you see that there's a little note here at the end. It says Harris was found dead on July 22nd and ruled a shooting victim. So the word shooting occurred in the little description here, but in fact the cause of death was blunt force. And so, so this person is not a shooting victim. And so, but the word shooting does occur. So that's why you have to filter on the right pattern to make sure you kind of get the right count there. So, all right. So by default, grep will return the indices into the character vector where a match occurs. Okay. But if sometimes you don't want the indices, you want the actual values of the things where the match occurs. So you can either just plug in so here if I say this vector here, state.name, it's just the name of all the 50 states plus Washington, D.C. And I say grep, now the pattern here is caret new, right? So what that means is that I want the string to begin with the word new, capital N-E-W, all right? That's the pattern. And you see that entries 29, 30, 31, 32 are the ones that match. Now I could just plug these indices into here and get the names out, or I can just set value equals true in the grep call, and it gives me the 4 names right away without having to do the extra step of plugging the indices in. And then grep L is just a variation of grep. If I call it on this, it gives me a logical vector that's the same length as this character vector here, but it's true or false, indicating whether or not the pattern matched on that string or not. So you can see that it's all false, except for the 4 right here, which are New Hampshire, New Jersey, New Mexico, New York, right? So those are the only ones that match. So sometimes you need a logical vector like this if you want to do some subsetting or something like that. Okay. So a couple limitations for grep. The function tells you what strings which strings in the character vector match the pattern, but it doesn't tell you A, what the pattern is, or where it's located in the string. And so if you're just matching literals, then you know what the pattern is, because the pattern is just the literal thing that you match. But if you've got a complicated regular expression with meta characters, then you don't always know exactly what the match is going to be. And so you want to be able to, you might want to know kind of what is the actual match that occurred that's embedded in this long string. So the regexpr function, if you have a better pronunciation, please let me know. But the regexpr function gives you that information. It tells you, okay, which character in this string does the match occur? Where does it begin? And then how long is it? How many characters is the match in this string? And so it gives you that information for every element of the character vector, assuming it matches. If it doesn't match, it just gives you -1. So for the index. Now, one thing to know about the regexpr function is that it only gives you the first match in a string. So if you have a pattern that occurs like 5 times in a string, it's only going to tell you where the first one is. Okay, so if you want to know the location of all of the matches in the string, you need to use the gregexpr function. The G stands for global. So it shows you all the matches in a given string, not just the first match. And that's the same distinction for sub and gsub, which you'll see in a second. So for example, if you want to find the date at which a homicide occurred, the date is embedded in here. See, it's in this little field right here, flanked by the DD tags here, right? So basically, the format is found on January 1st, 2007. So it's found on, and then the date, okay? So you could just grep, so what if you just grep on found, right? You could just do that. And what's that going to give you back? So now, well, I guess I don't really mean grep here. I mean, you could use the pattern found to try to extract the date part. But one of the problems is that the word found may occur, for example, in this comment here, Wheeler's body was found on the ground. So you don't want to just grep on found, because the word found will occur on 2 different places. And so one thing you can do is say, okay, well, in this string, the pattern is always kind of this angle bracket DD, angle bracket found on, and then the date. So maybe we'll include that little bit just to separate it out from where other places where the word found may occur in the string. So we can use the pattern. So I've got the angle, so the DD tag, and I got found, which could be capital F or lowercase f, a character class. Actually, it occurs to me, I don't need the little, you don't need this thing here. I'm not sure why I put that there. And then, so I say found, and then followed by anything, right? So dot star, remember, is anything. And then close with the kind of the /dd, so you close the dd tag there, right? So what does this find? So I can call regexpr with this pattern here. So found and then anything. And I'm just going to do it on the first 10 elements of this vector. So now, so what it does, it returns an integer vector here. So there's 10 elements here. So all of the elements in the character vector matched this pattern because they all have a date associated with them. And so the numbers here indicate the character where the match begins, right? So the first time it finds this pattern occurs at character 177. So if you just counted 177 characters from the beginning, you'd be at where that match, including spaces, you'd be where that match occurs, okay? The second string, it occurred at the 178th character, 188th character, et cetera, in the third string. And then the match went on for 93 characters, including the first character, right? So the entire match was 93 characters long, and it started at the 177th character. And you don't have to worry about this use bytes thing here. So if I wanted to see what the match is, I can take let's just take the first character string in this vector, and I can use the substring, or the subster function, which takes a character string or character vector, and takes the kind of the starting character and the ending character, and it will extract out that string. So now I know it starts at 177, and I know that's 93 characters long. So I can say I can start at 177, I go 177 plus 93, but then I need to subtract off 1 because this 93 includes the first character. So I'll just subtract off 1, and then you can see it extracts this string. But actually, the string is longer than I wanted it to be, right? I only wanted this part here found on January 1st, 2007. But it actually got this other stuff here. And why is that? And the reason is because when I use the dot star, the asterisk meta character is greedy, right? And so it's going to find the longest pattern it can find that matches that pattern. And so basically, what is it saying? It's saying I want a DD tag with a found, and then anything followed by a closed DD tag, right? And so I got DD found, and then anything, and I close DD right here, right? So it grabs as much as it could while still satisfying the regular expression pattern, okay? So that's not what I want. I want it to basically go start here, say found on, and then just stop right here, right? So I want to make the pattern lazy, actually, and so I need to use the question mark. I don't want it to take the whole thing together. So the pattern I actually want is dot star question mark here, and when I use regexpr on that, you see that the match length now is a lot shorter. It's 33 characters, not the 93 characters it was before. And when I substring it out, you can see I just get the part with the date. Okay. Now it's not exactly what I need because it still has some extra bits in it, and so I need to strip out. I want to strip out these HTML tags, and I don't need the found on part. I just want the January 1st, 2007 part. Okay. So how do I do that? So that's well. Before I do that, though, you can look. There's another handy function that's fairly recent in R. It's called the reg matches function, and it takes information that the regexpr function gives you, and it helps you kind of extract out the matches. So the way I did it before is I used the substring function to extract out the matches, but this will just kind of do it in a much more efficient way. So I can call regexpr with my pattern here. Here I'm just using the first 5 elements, and I just give it I take the output from regexpr and just pass it to reg matches. And now it automatically extracts out the strings that I wanted. Okay, so that's a much more efficient way. Well, I don't know if it's much more, but it's a somewhat more efficient way to extract the matches that you want without having to call substir on every single thing. All right, and we'll come back to this handy function later. All right, so now I still have this kind of garbage here, this DD tag here, this found on bit. So I want to kind of extract that out. So you can use the sub function or the gsub function to do that. And so I'm going to take this string, and what I want it to do is I want to remove everything before the January and remove everything and basically just remove this tag, right? And so what I'm going to do is I need a regular expression that matches this part and then this part. So that's going to be this here is going to be DD and then found with a capital or lowercase f on, so found space on space, right? And so that's one part. Or it can match this closed DD tag. Okay, so what this pattern is going to match this or that, right? And then so sub is going to try to match this pattern, and it's going to replace it with something that I specify here. In this case, I specify nothing. So I want to replace it with nothing. So basically, I just want to strip it out. Right? You could replace it with something else, like any other string that you want. But here I just want a blank. And then I give it the character vector here. So now you'll notice that when I strip it out, I get this, which is close. Right? It's not exactly what I want. I still have this closing DD tag here. Right? And the reason is when I use sub, it only replaces the first match in the string. Right? So when I take this pattern, where's the first place that it matches? It's right here, right? This is the first time you can see a match. And so what it does is it takes this match, replaces it with nothing, and then it just stops. It doesn't go on to the next match. So if you want to go on to all of the matches in the string, you have to use gsub. And so gsub will take this pattern, and it will match it as many times as possible in the string and replace it with, in this case, nothing. And so now I get the date out just like that. Okay. And so the sub and in this example here, I just have a single string, and that I'm trying to like sub and g sub out of. But actually the argument here, this x argument here, this could be a whole vector of strings, and it will just go through all the strings and replace the text, the pattern that you want. And so here I can give it, so I'm giving it 5 elements here. So I take all the these are all the matches that I found. And then what I'm going to do is I want to take all of these strings here. These are 5 different strings here, and I just want to I strip out all the DD tags and the found on bits. So I can call gsub on this whole vector of strings, and then it just gives me the whole vector of dates here. So you don't have to operate on a single string at a time. You can give it a whole vector of strings. And the last little bit here, I'm not going to go into too much detail for the moment, but these dates here are character strings, right? And so they're not dates. They're just sequences of characters. You can convert them to the date class in R using the as.date here. And what as.date does is it takes a character vector, and it basically reads the character string and converts it into an internal date format, which is a numerical value, okay? And so, and there's a special, and you have to give it the character vector in what's called a formatting string. And I'm going to talk separately about dates and times because it's like a whole topic to talk about. But basically, this formatting string says that the format of the date is going to be the month in an unabbreviated form, the day, comma, the year with 4 digits, the 4-digit year. Okay. And then when I call as.date, I get this. So now it looks so it looks like actually I haven't done anything. It looks like I just got back another character string. But actually, it only prints this way. Internally, when you call as.date, it stores it as what's called a date object. And then the date object is very handy because you can use it to like do numerical calculations. You can do differences between days and things like that. And R will internally account for things like leap year. So if you take the difference between two dates and it's like a certain number of, it's like it's more than a year. If there's a leap year in between, it'll add the extra day. All those things for you. And so, so the date format's quite handy, but I won't go into more detail at the moment. So the last function I want to talk about is this regexec function, which is it's a very handy function. And the basic idea behind it is that and this may or may not make sense for the moment, but it gives you the indices for any parenthesized sub-expressions in your regular expression. Okay. So what does that mean? So here I've got my regular expression for figuring out the date. And I know the date's going to have roughly this pattern. It's going to start with the DD. It's going to say found on. It's going to be a space. There's going to be stuff here. And then it's going to close with the DD. And I use the star, but I make it lazy so it only gets the one instance. So when I call regexec on here, so notice I have parentheses around this stuff here. Right? You don't have to have parentheses, but I do here. So what happens when you do this? Well, I get an index, so there's only one string here, so I get a list back with a single element. This indicates the list. And it tells me, the first number here tells me where the match begins. Okay? And it starts at the 177th character. The first number here for the match length attribute tells you how many characters how long the match is, right? It's 33 characters. The second number here tells me where the parenthesized sub-expression begins, right? So what that is that's the little bit that's matched by this part, right? In this case, this part that's matched over here is going to be the date, right? So this little sub-expression here starts at character 190 and it goes on for 15 characters, okay? So that's actually quite handy because now I don't have to bother with stripping out all this other stuff. I can say, give me the part that's just right there. Right, and I put it in parentheses just so you can find it. And now I know it starts at character 190 and it goes on for 15 characters. Okay. If I didn't put the parenthesis here, right? If I just did it like this is a valid expression, and it would have found this whole thing. See, it starts at 177 and goes on for 33, but it doesn't give me the little sub-expression in the middle because I didn't put parentheses around that part. Okay. So if you want to define a sub-expression in your pattern, you need to use parentheses. The parentheses themselves otherwise don't do anything. So how does this work in practice? So I can match this pattern in my string. I'll just take the first one. You've seen this already. Now you can see that if I just take the substring that's 177 and then plus 33, I get the whole match. So this is the whole match. And then but the parenthesized sub-expression here starts at 190 and it goes on for 15. That's this part here. That's the date, right? So that's exactly what I need, right? And so, now I can get all. So now when I call regexec, and let's say I do it on 2 strings now, just to generalize it. So the hardest part, remember, anytime you generalize something, is going from 1 to 2, right? And then 2 and beyond is all the same. So when you have 2 now, so regexec gives me the indices, the stuff that you've seen. Now I can call reg matches on this vector and then the stuff that came out of regexec. And what it does is it gives me a list, and each list, each element of the list gives me a character vector where the first element is the entire match and the second element is the parenthesized sub-expression, right? So now I'm going to have this list where I've got the match and then the date here, the match and the date. And so if I want the dates, I just need to L-apply or S-apply over this list and extract out the second element from each character vector, and then I've got all the dates. So, so if you wanted to, for example, make a plot of all of the counts of the number of homicides that occurred every month for the last 5 years, you can do this in just a few simple commands. So you can take the data set that I gave you, so you can read it into this object here. I call regexec to find all the kind of the date fields, and I use this parenthesized sub-expression. I call reg matches to get them parsed out, and then I S-apply over this list, and I extract the second element, right? So the second element is going to be these bits right here, right? So I S-apply over that whole list, and I say for each object, I just take out the second element. That's all I want. And then what do? I take that. So now I have this dates vector is a character vector of all the dates. I want to convert that into a date variable, so I just use the as.date function. And then I call hist, and I tell it I want a monthly histogram. So I say I want to aggregate the dates by month and give me a little bar. And so when I do that, the picture looks something like that. Right? So this is the monthly count of all homicides in the city, starting with 2007 and then going all the way roughly to 2012. So you can do that very quickly just by kind of a careful use of regular expressions and just literally 5 lines of code. So regular expressions are very powerful because they allow you to look through this messy text, and as long as you can kind of conceptualize what the pattern is going to be that you're looking for, right? Then you can kind of write it down in this format, and there's a lot of flexibility here. This is just a very basic pattern. Then you can extract out a lot of information very quickly from text data like this. So, anyways, and then you'll notice that I called hist on this date vector here. So hist is a generic function. If you call it on different types of data, it will do slightly different things. And so when you call hist on a date object, it requires a kind of interval in order to break it up into. So I could have made like a weekly plot. I could have made a daily plot. I could have made a monthly plot. Or I did make a monthly plot, but I could have made a yearly plot too. And so I told it to make a monthly plot, but hist will accept a couple of different types of intervals. Okay, so just to summarize, there's 4 basic functions. There's grep, regexpr, sub, and regexec. Grep will kind of search for the string, but it won't do anything. It'll just tell you whether the string matches or not. Regexpr will find where the pattern matches in a string, and it will tell you kind of what character it begins at and how many characters it goes for. The sub function will match a pattern and then replace it with something that you specify. And then the regexec function will give you the indices for these so-called parenthesized sub expressions, which can be very useful for matching specific things. So, and then the gsub and the gregexpr functions, they will find all the matches in a string as opposed to the first match, which is what the other functions do. One thing I want to just mention right now is that regular expression pattern matching is a little bit tricky in foreign languages. So if you happen to be operating on strings, that are in foreign languages, so and more specifically, non-ASCII languages, so they're either in a Unicode or a UTF-8 type of encoding. Then, so for example, there's other languages that have way more characters than the English language does, and so they need a totally different encoding system to represent those languages. And then doing pattern matching on that is greatly complicated if you're using these kinds of strings. So I'm not going to bother with that right now because it's like a whole area to talk about. So for the now, we're just going to assume that we're doing pattern matching on English language strings.